Hello guys, so in this video we will take a look at the 3D Analyst toolbar, and we will use some 3D Analyst to convert some contour lines or contour image to lines or polygons. So we will go to our course data folder, and we will go to 3D Analyst folder, and we will open our MXD 3 Analyst MXD, and you will find that we have one 10 layer, and 10 TIN is triangular irregular network. What that means is that this image have been created using a collection of triangles in a irregular way to show you the slope and the elevation for the image. So for example, if I click identify and I click anywhere, I'll see that here I have the elevation value from the sea level, which is 0, and here I have the slope, like the direction or the degree of the slope of this image. When we use ArcGlobe or ArcScene, we will see this in 3D, but right now we still can do some analysis on it and use it in ArcMap in 2D level. So when you click identify on any pixel, you will see the elevation, and you will see the slope, and you will see the aspect. So because we have this TIN layer here, we can right click here, and when we open the 3D Analyst toolbar, you will see that everything is enabled. And if you have several 3D layers, you can choose which one you want to work on from here. So let's see what the options we have here. Here we have a create contour line, and this will, whenever I click, it will create a line as contour line. So you cannot see it right now, so let's change the display for this layer to, let's say for example, make it 80%. So as you see now, whenever I click, it will create a line for the contour, which is the area that match the same elevation. So here I create another one, and here you can keep clicking anywhere and you will keep creating contour lines. But these lines you are seeing right now, just graphic, it's not an actual lines or feature lines or polylines, it's just graphics on the map. And we can right click, say draw, and we can come here and say convert the graphics to features if you wanted to convert these lines to features. But we are not going to do this right now because we are going to use another tool that can create contour lines for the entire image we have. So let's delete this graphics we have right here and see what else we have here. So here we have create a steepest path, and steepest path will, whenever you click, it will show you if, for example, you have water drop and it drops on this point right here, it will go through this path. As you see here in the image, let me change the display again. As you see here, the areas that have gray or darker colors, this is the high elevation areas, and the ones that is green is actually lower elevations. And here in this area here, we have the colors matching this slope. So that means that this slope is actually starting from the top, going all the way to the sea level. So if I click here to see the steepest path, I will see that it actually starts from the top all the way to the bottom, going right away to the sea level. So that's the way you can use the steepest path to determine how steep is this area and where actually it might end based on the slope values. And here the next tool we have create line of sight. So let's say for example I am standing right here and I want to look in a straight line all the way to this point right here. When I click, you will see that the line have some red areas, and the red areas means that I cannot see that if I'm looking at horizontal straight line, and the green parts means that I can see this area. And the green parts means it's either higher in elevation than where I am, or I can see the slope of the elevation going up to this green point. So sight of line will help you to determine from this point to another point what is the elevation looks like, just to give it like a description. So let's draw another one from here to here and see the sight of line. As you see, you have some green areas and some red areas. You can also create a graph out of this because it's a line. So we can create a graph and we can see it in a better way on the graph. Now we can see how the sight looks like. So here it shows you the elevation for the points along the line, and here it shows you where's the area you can see from this point to this point, and what is the slope and the elevation looks like on this path. So also you can work with this graph as you work on any graph, like right click and you can add it to a layout if you want. You can copy this graph and paste it on Word document, or paste it, like for example Microsoft Paint, you can paste it here. So copy graph will help you like copy this graph and paste it anywhere. Also you can come here and export it to any of these formats right here, like JPG, GIF, PDF. So there's different things to work on this graph right here, and you can change how the x-axis looks like and the y-axis looks like by going to properties. So this is specifically for the graph, but here it shows you how your line of sight looks like. The next tool we have here is to create a point on anywhere. So any point you create, or line or polygon, this polygon, lines and points will automatically fit itself based on the elevation under it. So if we open this graphic or did the same thing in ArcScene, you will see that this polygon or this line actually matching the 3D of the surface below it. So when we draw a line or a polygon or a point using these tools right here, it matches the elevation using the elevation value of it, and the polygon will look exactly how the surface looks like. And here the last two icons is to open ArcScene, and here to open ArcGlobe, and we will open ArcGlobe and ArcScene in a different section. So now let's see how can we use some analysis tools to convert this TIN layer to contour lines. So let's remove our graphics from here, we don't need it anymore, and close this one. So now we will go to the search window and we will search for contour, and you will find that here we have a tool called surface contour. So we are going to open this one. We are going to add input as this file TIN, the one we have right here, and you can change the output location, but we are gonna just view how this looks like, so we are gonna keep the default. Here the contour interval means like what is the interval between each line. So for example, here you see the values starts from 0 up to 262. So if we make an interval of 20, that means we will have 13 or 14 different classes for the contour lines we have. So here we will enter 20, and I'll keep everything in the default. There's so many different options here you can set, so I'll say OK. And it's processing right now. As you see here, here's the processing window. It says succeed. It added to the map, and as you see we have a very thin lines right here represents the contour. So let's hide this one, and now you have your contour lines. Some of it is closed, so we can actually convert this to polygons, and we will see how to do that right now. And some of it is not closed because it continues out of our image extent. So if I right click here and say open attribute table, you will see here that you see the contour values, the contours that have 20, and you have the shape length for the lines, and we have 0, 20, 40, and it will keep the interval going 20, 20, 20 up to go to all the way to 260 as we have it right here. So in order for us to categorize all the lines based on a contour value, we can use another tool called dissolve. So if we go to the search window and search for dissolve, or actually you can open it from geoprocessing window here. This is one of the tools that exist in the geoprocessing menu because it's used a lot, so we can use it from here directly, or you can open it from here, it's the same. And we will enter our input as our surface contour line, and we will keep everything the same. Before we click OK, make sure you choose this field, or you right click on here and say select all. For some reason this tool, the output will be empty if you didn't select the features you want to add as an input. So let's just select, say select all, make sure it's selected, and say OK. We check our processing from here, it's finished and it's added to the map. So right now I have another similar layer, it's a line as well, but when I open the attribute table for it, and let's compare with them next to each other. So let's go to arrange table vertically, and here we have the dissolve one. It have one value for each contour value. So here I will have about 13, 14 values, and when I select, let's clear the selection from here. And when I select one, it will show me all the features that have a contour of 100. So here all the lines that have a contour of 100. And this is a good way to categorize all your lines in one category under the contour value. So right now you can view the contour value for all the lines at the same time. So the last thing we will do here, we will try to create polygons out of these lines. So all the contour values or all the contour lines that is closed can be converted to polygons. So we can go here and search to polygon, and we will run feature to polygon, and we will add our input feature, any of this two features layer, because it's already the same one, so we will add this one. and we will say here's the output. We'll keep everything the same. I'll just say OK, and you will see right now on the map that we have a polygon layer been added to the map that represent the contour areas that is closed inside our map right now. And one more thing before we end the video I want to show you is the illumination. So let's enable this layer again, hide all the other layers. So we will pan a little bit here, and I will right click here on the data frame. I say properties, and we will open the illumination tab, and this one will represent where the sun location is, so we can see the light like it's coming from the sun. So we here can change where the sun location in the north, in the east, south, or west. And as you see here, when you change these values, this preview here, it shows you where the sun or the light coming from and where the shadows will be. So here, for example, let's add it to the west, and let's make the sun exactly on the top. That means that everything is have light on it. If you put it right here, everything is dark. So you can put it right here on the middle, and you can change the contrast from here. And every time you click apply or OK, you will see that your image and your representation here changed based on these values. So if I make it like that, the light is coming from the west. So if I make it to the east, so this is like sunrise time. I'll say apply, and this is sunrise time. Sunset time will be here, and the same way here, play apply, and this is sunset time. So that's a different way to represent your data based on where the sun location is. And I will restore to default, say OK, and we will return everything the same it was, and we are going to save our MXD. So that's basically how you can use some 3D analysis, how you can use the 3D Analyst toolbar to view the site, the slope, the elevation, create some 3D analysis like we saw right now on any 3D data. And that's it for this video.